All right. It looks like a good time to start right now. So today we're gonna be going over some rate problems. I don't have like introduction material, because most of it would just be centered around one equation that I'll just go over later. But rate problems are pretty hard, I think, unless you know how to do them. Like I remember when I encountered a lot of rate problem in math counts and stuff. They were hard initially, but the more you practice them, the easier they got. So let's share. Okay, so let's start looking at this first problem here. I'll give you guys like a couple minutes. Yeah. Wait, okay, never mind. Yeah, we should actually start with this problem. I don't know why the document went all the way to page 3, but we're starting here. All right, okay. Great job, Ishan. Yeah, and Kevin. Yeah, the answer is 125. So here we're going to be using, for all of our problems, we're going to be using the equation speed equals distance over time, right? And if we look at this, we know that the speed or the rate, here we have rate slash speed are mean basically the same thing. So the speed is 100 miles in 2.4 hours, and you drive for 3 hours at the speed, right? So S times T equals D, so we multiply the speed times the time for the distance. And looking at this, I think this is 125 if you do some arithmetic. So this is pretty easy, right? Like you guys understand this. This is just like an introduction to how we're going to be using speed and rate. All right. Okay, that's good. Right. Now let's look at the second problem here. Okay, we're getting some answers. 68, 52, 52. Okay, 52 is close, but it's not quite right. Um, yeah. 68 is also close. It's just, I think you guys should read the last sentence again. Right, good job. Yeah, it's 26. Yeah. So, maybe for this problem, we should start by looking at how many miles she drives, right? So it's 2 hours times 60 miles per hour is 120 miles total, right? And if she gets paid $0.5 per mile, that's $60 total. And her car gets 30 miles per gallon, so it's 120 miles over 30 miles is 4 gallons for the entire trip, right? And we know that gasoline is $2 per gallon, so it's $8. So it's $60. Subtracting $8 is $52. But of course, we have to divide it by 2 because it's 2 hours at 60 miles per hour and it's dollars per hour. So the total is 2 hours and we have $52 for 2 hours, so it's $26 for an hour. Does that make sense? All right. So, this is good. And if you ever have any questions, don't be afraid to write something in chat. But if we're good with this problem, we can go to the next problem. Right. Oh, okay. Why was it subtract 8? So here we know that she earns, she is paid this much for her driving, so she's paid $60, right? And her only expense is gasoline. So an expense is it's like something that she's paying for. Like, she's paying for the gasoline herself, and people are paying her to drive. So the $8 is taken out of her own wallet. Yeah. Okay. So the expense is something that she's paying, and this is what she's getting paid. Yeah. Okay, so now we can go to the next problem. Samya. Um, 4 is not quite right. It says round to the nearest tenth, so we know that it's a decimal. 3.7, closer, but it's still not correct. It's okay. This problem is the hard part is getting the equation. So 2.8 or maybe 2.9. Yeah, 2.8 should be the right answer. I'm not quite sure how you guys are getting 3.7, but if you guys put your equation in chat, we can compare how we got to our solutions. Right. Oh, okay. 44 over 60 times 5 is the distance. Oh, okay. So I see what you guys are doing wrong here. So we have she's traveling at an okay, so let's look at um okay, let's look at this. So let's say that this is her house. This is her friend's house. Okay, friend. So she traveled half the distance at 17 kilometers per hour, and the other half at 5 kilometers per hour. And the total is 44 minutes, right? So I think you guys only calculated for the walking part. Hello, Jake. It's okay if you're a little late. The first two problems that we went over were relatively easy, so you can just look at this problem. Okay, so I think most of you guys have been able to look at this a little bit. So we're gonna look at the equation. So we're setting up an equation for this problem. It's okay. So let's say that the distance. We want the entire distance, right? But let's say that this part is called D, right? And this part is also called D, because it's the same distance. So the total is 2D, but we're separating into two parts. So D over 17. This is the time for the first one, because D equals S times T, and D over S equals T, right? I think that's what Kevin used. Oh yeah, D equals TS, D over S is equal to T. Anyways, so we have the distance over the speed is the time. And then we also want the time for the second half, which is the distance over 5 kilometers per hour. And we get 44 minutes, but we can express this as 44 over 60 because it's in kilometers per hour, right? So this is the equation that we're getting to solve this thing. Does that make sense? Does everyone see how we like set up the equation? You can just put a yes in chat if you got it, or if you have a question, just let me know what the question is. Yes? Okay. Yeah, that's good. Okay, so now we have this equation, and it'll be easier to get our answer because this is just like simple algebra. We can get 22D over 85 equals 22 over 30. D equals 85 over 30, and 2D equals 85 over 15, which is 17 over 3, which is wait um hum I seem wait okay, I think I made a mistake here. um oh, okay, yeah, we only want the D, right? Whoops. Yeah, never mind. Okay, I'm sorry, I wrote the question a little bit wrong. It says how far did Samuel walk, which means that we only want this second half, which is 85 over 30, which is 17 over 6, which should be, 2.8. I think this is good, right? Sorry, guys. I have a little bit of a brain freeze. Does that look good, guys? I think that's right? You can just say yes or something in chat if that's correct. How did you get 222, D? Okay, so I found a common denominator here, so it's 5D over 85 plus 17D over 85, which is 22D over 85. Right? If you simplify this, you can get these things. Yeah. Okay. So, yeah, that's all right. We're here. Don't be afraid to ask questions because I'd rather you know how to do something than know the answer. All right. So, do we feel good to move on to the next problem? Yeah. All right. So, let's look at this problem. This is a nice problem. I think you'll see a lot of these kinds of problems: painting the house, having workers. Yeah, good job, Toby and Joshua. That's right. All right. We can start on this problem now. So we have a good worker. Yeah, that's correct, Ishan. It's 3. So if you have a good worker, um, can paint the house alone in 12 hours, that means in 1 hour, or in 1 hour, they can get 1/12 done, right? And painted in 3 hours. So if they have 3 hours to paint, they get 3 times 1/12, which is 1/4 done, right? This is for good workers. And we have 3 good workers, so we have 3 times 1/4 equals 3/4 done, right? So now for the bad workers. Suppose we have 1 hour, they have 1/36 done, right? And we know that x, which is the number of bad workers, times 1/36 times 3 for 3 hours equals to 1/4, right? Because 3/4 has already been done by the good workers and 1/4 will be done by the bad workers. So I think x over 12 equals 1/4, x equals 3, right? So this is the equation that we wanted to find that was important for this problem. You'll see that in a lot of rate problems, the important thing is to find a good equation and then it'll be easy from there. But yeah. I think this is a relatively good problem, an easier problem, but it uses a lot of the fundamental ideas that will be used in harder problems. So I think we're good to move on, right? All right, that's okay. We'll just move on anyways. So now we have this bike ride again. Right. For this problem, I want you guys to think about the equation and what kind of equation you were using, or what equation did you use to find the answer. Maybe don't put it in chat yet, but once everybody has had a chance to think about it a little bit, you should put your equation in chat so we can all see how you were able to get to your answer. All right. Yeah. The answer should be 30. Okay, Toby, that's if we can look at that scenario later, but that's not exactly how rate works in speed and stuff. Yeah, so 30 is the correct answer. Okay, that's good. But I want you guys to show me like how you guys got 30. Like what was your equation, or what were you thinking? And I'll give you guys a minute to put in chat. If you guys don't want to share or don't really know how you got the answer, it's okay. I can go over it. First part, 80 minutes, 40 minutes left to do 20 kilometers, which is 30 kilometers. Okay, yeah, let's solve it that way. So, we have 20 kilometers per hour for the entire trip, right? Oops. Here. How many kilometers per hour must his average speed be during the second half of the trip? So it's 40 kilometers bike ride, so it should be 2 hours, right? 2 hours. If the first half of the distance, 80 minutes to travel the first 20 kilometers for 15 kilometers an hour. So in order to average 20 kilometers an hour, you would need to travel 40 kilometers in 120 minutes to 40 minutes left for 20 kilometers. So there would be 30 kilometers an hour. Okay, yeah. So 20 hours, or for 2 hours, the first half of the distance averaging a speed of 15 kilometers per hour. Right. So we have 15 kilometers per hour. So it's 20 over 15, right? Hours, or we can convert it to minutes. So we have 120 minutes equals to 80 minutes plus, and then for the second half of the trip, we want it to be 40 minutes. But we also have 20 kilometers. So 20 kilometers in 40 minutes is 30 kilometers per hour, I think. So that's true, right? Yeah, okay. Helen, that's the equation that I was looking for. So that's how I was going to show how to solve it. But we can look at this one this way too. So it's actually 2 hours, 20 hours, 20 over 15 hours, which is 10 over 15 hours. So this is the second half. 10 over 15 hours is 2/3 of an hour in 20 kilometers. So this is 30 kilometers per hour. Right? So I think if you just calculate the number by the number of minutes or by the number of hours, that would be pretty good. But I think a nicer way to solve this would be to consider um, an equation first to solve it. So we have 40 kilometers or 20 kilometers for the first half over 15 kilometers per hour plus 20 kilometers for the second half over s kilometers per hour, we don't know yet, equals 2 hours, right? And if we solve this equation, we get 20 over s equals 10 over 15, and s equals 30. So this is much nicer, right? Without having to go through all the minutes and subtracting and converting, right? Does this make sense, everyone? This equation is much nicer than the other one, simply because it's just it's like one step. We don't have to do all the converting. And then now, if we look at what I think Toby said, yeah, Toby said 25 kilometers per hour. Let's look at this for a minute. So if we have 15 and 25, we have 20 over 15 plus 20 over 25, right? And I'm not sure what the answer would be, but let's look at what this would get us. So this is 4 over 3 plus 4 over 5 equals 32 over 15, I think. And if we want it to be 20 kilometers per hour, it should be 2 hours, and this is not equal to 2. So sometimes we just can't average out the speeds because it won't work. We have to set up an equation. Does this work for everybody? Do we get how I got this equation and got this answer? Just put a yes in chat if that's good. Yeah. Okay, thanks, Joshua. And good job, Helen. That's a really nice solution. It's what I use, and I think it's pretty good. But also good job, Ishan, and whoever the anonymous Q&A was. Because that's also a very valid way to do it, and it's a good way to do it. This problem is really easy. Let's go to the next problem. How does 20 over 5 convert to 10 over 15? What was it? It was 20 over 15 plus 20 over s. Okay, let's not use the variable s because it looks like 5. 20 over t equals 40 over 2 equals, or 40 over 20 equals 2, right? So 20 over 15 plus 20 over t equals 2. If we subtract 20 over 15 from both, 2 minus 20 over 15 equals 30 over 15 minus 20 over 15 equals 10 over 15, and 20 over t equals 10 over 15. So t equals 30. Does that answer your question, Toby? All right, so are you not sure about how we got the equation, or are you not sure about how we solved the equation? Oh, you get it? Oh, okay, that's nice. All right. All right, so I'll give you guys like a 2-minute break, and then we can go on to this next problem. You guys should take a chance to just clear your minds. Maybe go use the restroom or something. Yeah. Oh, yeah, you're right, Ishan. That was the answer to the question that we skipped. Yeah. Good job. All right, so break is over. You guys should start looking at the problem now. And 360 minutes, yep, that's correct. We're going to be going over that in a minute after everybody else has a chance to read it. All right, let's start on this problem. A basement has, yeah, that's right, Kevin. 360. So let's look at this. We have 24. Should be a 24 by 32 by, we know that 18 inches is equal to 1.5 feet, right? So 1.5. So this is the amount of water in there in feet. We know that each cubic feet contains 7.5 gallons. So times 7.5, right? So this is the amount of gallons. And then we also know that there are 3 pumps used to pump water, and each will pump 8 gallons per water. So it should be divided by 3 times 8, right? This is the amount of water that's being pumped out per gallon. So I think it's just multiplying these out. Right? So we get 360. So how did we get this number? You guys might ask. Oh, you thought inches was feet? Yeah, that's all right. That can be hard to read. Yeah. So it's 24 by 32 by 18 inches, which is 1.5 feet. And then this is the amount of cubic feet, but times 7.5 over 24, right? Does everybody else get this? Maybe I should run a poll. Yeah, Joshua. That's good. I don't know how to run these polls. Yeah, maybe just like everybody can put yes or no whether or not they get it, so I can see if everybody gets it. This one, it's hard to have an equation because it's mainly just the numbers being multiplied, so it might be a little bit hard to understand. Oh, okay, yeah, that's a lot of yeses. Why is it divided by 24? Okay, because there's 3 pumps and each pump is pumping out 8 gallons of water. So if we have like the tank and we have the pumps, there are 3 of them and each one is 8, so it's 24. Does that make sense? All right. Okay, I think that's basically everyone that participates in chat is good with it now. So we can go to the next problem. Or this one's a nice one that's just an equation, I think. Yeah, maybe. So for this problem, I think it's good to start by calculating the total distance. And then also calculating the total time so we can divide it. Yeah. So I'll give you a minute to think about it, but a hint would be to find the total distance and then the total time and then dividing those. Oh, okay. So there looks like there's a lot of answers coming in. 51, 51, 51, 51. Yeah, 51 is the right answer. All right, that's good. Let's start by solving this though. So the distance is 20 kilometers, right? For the first part, 25 kilometers for the second part, and then 60 kilometers per hour times 3/4 hours is, I think, 45. So 45 kilometers plus 48 kilometers times 1/4 hours, and I think this is 12, so it's plus 12, right? Does this work, everybody? Yeah, I think this sums to 102. Yeah, okay. Yeah, so 102 kilometers. And then for the time, we have the first one is 30 minutes plus the second one is also 30 minutes, right? We can see just by dividing 40 or 20/40 equals 1/2, and then 25/50 equals 1/2. And we have 45 minutes and then 15 minutes. And I think this is 120 minutes, which is 2 hours. So dividing, we get 102 over 2 hours equals 51 kilometers per hour, right? So I think this is a relatively straightforward question once you got everything in distance and time. If there's any questions, don't be afraid to ask, but I think this was relatively easy and we could go to the next problem, right? All right. Um, I think we're going pretty fast today. Do you guys think my pacing is too fast or too slow today? I think we're going through our problems pretty quickly. So maybe I'm talking too fast or explaining too fast. If you ever need me to slow down, just tell me. It's fine. Oh, okay, that's good. What about the difficulty of the problems, do you think? Do you think today was a little bit easier than normal? Level 0? Right? This type of math is easier. Yeah, once you figure out the equation, it's relatively simple for the rates. Okay, so if everyone's good, let's look a little bit at this problem here. David drives from his home to the airport. I'll give you guys some time to look at it and stuff, and we'll solve it later. Yay, all right. So I decided to give you guys a little bit more time because this is a tricky problem, right? But Kevin got it. Yeah, it's 22 or it's 210. Do you want to say how you got the answer, or do you want for us to wait a little bit? Right? Does everybody else want us to wait a little bit, or can we just go over everything right now? Wait. All right, I'll give you guys a minute to wait. Yeah. This problem is a little bit trickier if you guys um think about it as the entire distance, but I'll give you guys a hint, and I want you guys to think about just the distance that um after he realizes he'll be late, right? Let me draw a diagram really quickly. Right. So this is the 35 miles in the first hour, and then this is D for the second hour. Or not the second hour, just like for the rest of the time. I think you guys should just focus on this part without taking care of the first part. I think it'll be easier for you guys. Yeah. The hint? Oh, the hint was to just ignore the first hour and just focus on the second part. Not quite, Thomas, not quite. Okay, another hint would be to consider the difference between the times, right? The difference is 90 minutes, right? 60 minutes late plus 30 minutes early is 90 minutes. So 90 minutes is the difference, right? So I'll just let you guys think about that for a little bit longer. And then just put when you put like a yes in chat when you want me to go over the equation or the answer. Yeah. Okay, I should probably start explaining now anyways because we have two more problems and we're not done yet with this one. But let's consider this, right? So he drives 35 miles in the first hour, but realizes that he'll be an hour late if he continues at the speed. This means that D over 35 is an hour late, right? But we also know that when he increases his speed by 15 hours, it's D over 50, and the difference will be 90 minutes. Yeah, that's true, Kevin. Yeah. He drives the rest of the way at 50 miles per hour. So we have this is his initial time, and this is his faster time, and the difference will be 90 minutes. So we're not considering 60 minutes late or 30 minutes early. We're looking at the total difference, which is 90 minutes, right? Does everybody get how we got this equation? This is the first time, and this is the second time, and this is the difference between the times. Does that make sense? Just like put a yes in chat if that's good, and if you don't really get it, oh, okay, yes. Okay, yeah, so you guys get this. Great. So if we have this equation, once we get this equation, it's a lot easier. I think if you solve it, you get D equals 210, right? Or no, I'm sorry. D equals 210 minus 35. What is this? 15D over 35 times 50 equals 90. D over 350 equals 90. d over 350 equals 3. Oh, wait, sorry. Yeah, I had a bit of a brain freeze at the moment. This should say 90 over 60, right? Right, Kevin? I think this should say 90 over 60, right? Because it's by the hours. So 90 minutes is 90 over 60 hours. So I think if we look at this, it's 15 over 35 times 50 equals 90 over 60. So it's 3d over 350 equals 3 over 2. And d over 350 equals 1/2. D equals 175, I think. And then 175, oops, 175, okay, my pen is having a little bit of issue, but 175 plus the 35 initially gives us 210, right? Does that make sense for everybody? Does anybody have any questions? I think once we solve this equation and added the initial part back, it's 210. This equation might be a little bit hard to understand at first, so if you guys need a little bit of extra clarification, don't hesitate. Right, so everybody understands? Man, I really wish I knew how to work these polls so I can get a poll going. Can you explain the equation again? Okay, yeah, sure. Let's just clear this part and just go for the equation. We have this part is 35 and this part is d, right? If we go at 35 miles per hour, we're 60 minutes late. But if we go at 50 miles per hour, we're 30 minutes early. So the difference is 90 minutes, right? This is just the difference between the two driving times. So if we have d over 35, this is the initial driving time, and then the faster driving time, the difference should be 90 over 60 minutes. Does that make sense? Yeah, okay. So this is good. This is good with everyone. Sorry guys, I don't know how to unmute you guys, so instead of raising your hand, you can just type it in chat, or you can put it in the Q&A, because the Q&A is anonymous. But I think everyone is good. Oh. No, a quick review of 90 over 60. The reason why we have 90 over 60 is because it's miles per hour. 35 miles in the first hour is 35 miles per hour. And then if we increase it by 15 miles per hour, it's 50 miles per hour. And it's 90 minutes. And in hours, that's 90 over 60, which is 1.5. Does that make sense, Ishan? All right. So are there any more questions or are we good? Okay, so it looks like there aren't any questions. I think this one is a little bit of a trickier problem just because you need to think about the 90 minutes or the difference between the times rather than the time that he needs to be there by. So we don't need to count whether it's early or late. We just need the difference between the times. So I think this problem was a little bit trickier, but that's okay. I think we have enough time to go over this last problem, but we're gonna have to go a little bit faster. Okay, so I don't think we're gonna have enough time to go over this problem. So I guess I'll leave it as a homework for you guys to think about it. We only have 2 minutes left, and this is a harder problem. Maybe we can go over it at the beginning of next class, but um, I'm not sure we'll have enough time for it today. So I guess you guys are free to leave early today and just think about this problem as a homework. All right, yeah, bye. Um, oh, and by the way, why is week 2 Google Drive the principle of inclusion exclusion one rather than the Pythagorean theorem one? I think Rich is in charge of them. I just give Rich the documents, but I can talk to him about it. And yeah. All right, bye.